Good morning, students. So in the last class we discussed about the two types of sequential statements. So those are sequential signal assignment statement and variable assignment statement. Okay. So and also I mentioned that while you are assigning value for variable, we are supposed to consider the colon equals to as the assigning operator. And while you are assigning value for the signal, we are supposed to use the less than equals to as the assigning operator. Okay. So here next we are going to discuss other type of sequential statements that we have in VHDL. So in that first we are going to start with if statement. Okay. Anyway, in this particular if we have multiple forms. So here I considered all those multiple forms of if statement. Okay. And these are all the syntaxes for them. So coming to this, first we are going to consider the first form of the if statement, that is simple if statement. We can able to consider it as. Okay. So if you look at the syntax for that, it starts with a keyword if. Okay. So if statement always starts with a keyword if. Then after that we have the Boolean expression. Okay. So what is Boolean expression? So already in the previous classes I mentioned that Boolean expression combines Boolean terms using the VHDL built-in operators such as and or not, etc. So that is what the Boolean expression. Okay. Boolean expression combines Boolean terms using the VHDL built-in operators such as and or not, etc. Okay. And specifically Boolean terms. Boolean terms are nothing but Boolean variables or results of the comparisons using relational operators such as equals to, not equals to, less than or equals to, greater than or equals to. So already I mentioned that particular one. So in the same way, using of the same statement, here also you can able to describe that particular Boolean expression. Okay. So once this particular Boolean expression is going to evaluate, and finally we are going to get a result of either true or false, because here I am mentioning the Boolean expression, that is nothing but Boolean. Okay. While coming for Boolean, so the values for that particular one is true or false. So because of that, after evaluating this particular Boolean expression, we can able to get a value of either true or false. So by means of that, so after evaluating it, if you got that particular one as value as true, then it is going to execute, then is a keyword. Okay. Then it is going to execute the sequential statements. So in this particular sequential statements, either you can able to write a single statement or combination of multiple statements. Okay. So while coming for this particular one, whenever in this particular if statement, if the Boolean expression becomes true, its value is true, then whatever sequential statements we mentioned under that particular one, so all those statements are going to execute. So that is what going to happen in the first form, which is simple if form. Okay, simple if statement. So next to that, we are supposed to end that particular if. Okay, so wherever you started that particular if, okay, statement, so we must close that particular one by means of considering an end statement. That is what? End if. Okay. So because of that, so always if you started if, there must be an end if also must be present to terminate that particular if statement. Okay. So because of that, so finally we mentioned end if, then semicolon. So this is the first form. Then while coming for the second form of the if statement, so that is if else statement. Okay. So this is the syntax for that. If you look at this particular one, so always if statement starts with a keyword if. Then after that, Boolean expression. As I mentioned previously, it evaluates that particular Boolean expression. And once we got a value of true or false, based on that, if we got the true, then keyword, then is a keyword, then these are all the sequential statements are going to execute. So this one seems to be, explanation seems to be same as previous one itself. Okay. So if Boolean expression this becomes true, then these are all the sequential statements are going to execute. If this Boolean expression is false, then obviously it comes to the next one, which is else statement. Okay. Else Under else also I mentioned some of the sequential statements. So because of that, whenever this particular Boolean expression become false, at that time, so in else case, whatever statements that we mentioned, sequential statements, those are all going to execute. So because of that, in this particular case, if this particular one is true, then these are all the sequential statements are going to execute. If this particular Boolean expression is false, then in else, so we mentioned these sequential statements, and whenever this particular one is false, these sequential statements are going to execute, which are present in the else statement. Okay. So then after that, we are supposed to close that particular if by means of considering an end if. Okay, then there is no need to close this particular else at all. So just you started over here, because of that, to terminate that particular if, we are supposed to consider the end if. So this is the second form of if statement, okay, which is an if else statement. And next to that, so these two comes under the nested if then else statements. Okay, so these two belongs to that particular category, nested if then else statement. So while coming for this particular one, so here also, so started with a keyword if, then Boolean expression. Okay, same as previous one, is going to evaluate. If that is true, then these are all the sequential statements are going to execute. If this particular Boolean expression got false, then obviously it is going to the next statement. So unlike previous one, if it fails, it executes these statements. Okay, if it fails, it executes else statement, whatever statements we mentioned in else, all those are all by default they are going to execute. But here the difference is, in else statements also we are verifying a condition. Okay, by means of considering else if statement. Okay, remember that else if. So you are supposed to write with ELSIF. There is no E over here. That is not ELSEIF. So this is ELSIF. Remember it. So majority of the students they will do mistake over here. Simply they will write ELSEIF. But in BHDL we don't have that particular one ELSEIF. Instead of that, so here we are indicating that particular one as ELSIF. Okay, there is no gap between S and I. Also remember it. Okay. So even in else also, else class also, we mentioned the, okay, so we are verifying the condition. By means of that only we are going to run those sequential statements. So in this particular case, else if this fails, then it comes to this particular statement, and here also it is going to verify the Boolean expression. If that particular Boolean expression is true, okay, value is true, then these are all the sequential statements are going to execute. Suppose this Boolean expression also become false, then it comes to the next statement. Okay, so here I mentioned and so on. That means so many else if statements you can able to write. So once if you got the last one, so if compiler comes to this particular statement, means whatever else if and if statements previously we mentioned, all those Boolean expressions become false. Then only it reaches to this particular one. Okay, then this is the last one, else if it is going to verify the Boolean expression. If previous all Boolean expressions are false, then compiler comes to this particular else if statement and it verifies this particular Boolean expression. And if it is false, then these are all the, okay, if it is true, then these are all the sequential statements it is going to execute. If this one also false, means then no statements are going to execute over here. Simply it will terminate by means of this particular end if statement. So this is what the third format. So which is nested if then else statement. Okay. So it consists of if then and else if statements. Then coming to the last form. So this is also belongs to nested if then else statements. So while coming for that, first it starts with a keyword if, then Boolean expression. If it is true, then these are all the sequential statements are going to execute. If we got the false over here, value as false, then obviously it moves to the next statement. Here also it is going to verify. If it is true, then these are all the sequential statements. If it is false, then control moves to the next statement. So and so on up to the last one. So this is the last else if statement. Okay. So while coming for this, here Boolean expression by means of verifying it. If it is true, then these are all the sequential statements are going to execute. But if it fails, okay, then so next control comes to this particular else. While coming for last statement, here I am not going to verify any Boolean expression, simply I mentioned else. So because of that, so whenever all these Boolean expressions in if as well as else if, all these are all fails, then obviously these are all the sequential statements it is going to execute. Because so here I mentioned else, that is nothing but if all the previous statement so we got as false, then obviously so these sequential statements are going to execute without verifying any condition. Else if means then only it is going to verify that particular condition. Simply else means without verifying any condition, directly those sequential statements they are going to execute. Okay, so that is the main difference between this one and this one. So in this particular case, if all the Boolean expressions so we got a value of false, then obviously no sequential statements are going to execute. But while coming for this, so because of at last we mentioned else, so here without verifying any statement, by default if all these Boolean expressions values become false, then obviously these are all the sequential statements are going to execute. Okay, and finally we are supposed to terminate that particular if loop by means of considering the end if. So here one of the important point you are supposed to remember is while you are writing else if, okay, so you need to take care about it. It is ELSIF, not ELSCIF. ELSIF. So these are all the different forms of if statement syntaxes. So first one is simple form, simple if statement. Second one is if else statement, and third and fourth comes under the nested if then else statements. Okay, so this is how the syntax seems to be for those if statements. So anyone you can able to use based on the application. Anyway, next we are developing a program for the prime number detector in behavioral description style, that too using of the if statement. So here I am considering this particular last one, fourth form of the if statement we are considering. So based on that, so I am going to define the functionality of the prime number detector. Okay. So once you get that particular syntax, using of this particular one only, we are supposed to write the program for that. Okay. So now let me move to that particular one. So coming to here once again I considered the prime number detector. Okay, so this one only, so from the starting onwards, so we are considering, because by means of considering a single example, okay, if we explain all these different description styles, then it will be easy for you to understand how these are all going to differentiate. So in that regard, I am considering the same example, and each and every sequential and concurrent statements that we are going to consider, I am going to explain using of the same. Okay, so here my intention is to realize the functionality of prime number detector by means of considering the if statement, that too fourth form of the if statement. Okay, so because of that, so here I mentioned the program. So this one also consists of by default entity declaration, library and packages, but all those are all seems to be same as I mentioned irrespective of the description style. So because of that, here I did mention library, package and entity part. So directly I come to the architecture, because within architecture only it is going to differentiate all those three description styles. In that regard, our focus is only in architecture definition only. For that reason only I considered only architecture. Okay. So anyway, architecture starts with a keyword architecture, then architecture name of entity name is, then after that, so begin. Okay. So after, so within the architecture body, we are supposed to represent the concurrent statement. Here I am developing program by means of considering the behavioral description style. In behavioral description style, the concurrent statement that we have is process. Okay. So because of that, so that is what I considered within that particular architecture body. Process statement where it starts with the keyword process and then sensitivity list. Okay, within parenthesis we are supposed to mention the sensitivity list. What we are supposed to mention, as we discussed in the last class, signals we are supposed to mention in that particular sensitivity list. What type of signals? Based upon those signals, if those signals can able to vary the output of that particular circuit, those signals we are supposed to mention within that particular sensitivity list. Okay. So in that regard, we consider that particular one. Anyway, prime number detector where output is going to vary with respect to input. So because of that, in that particular sensitivity list, we mentioned inputs. Inputs are nothing but N0, N1, N2, N3. All those we consider them as an array. With N we indicated in entity declaration part. Because of that, here I mentioned within that particular sensitivity list N. Okay, that is nothing but all inputs of the prime number I considered within that particular sensitivity list. Okay, then after that, okay, first, so here my intention is, so by means of using if I write the Boolean expression, each and every time I am supposed to verify that particular binary values. Because of prime number, okay, detector, it consists of 4 inputs. So total 16 input combinations. If I mentioned all those, every time I have to represent that particular in binary form. That means every time within double quotes we are supposed to mention those 4 binary values. It seems to be difficult representing all. So instead of that, if I can able to convert that binary value into integer, okay, so then it seems to be easy to write that particular program in terms of integers. So in that regard, here I considered that particular one. What I have done is, so first I developed a function, okay, where that particular function, okay, in architecture definition, before starting of the architecture body, some of the declarations and definitions we made over there. So type declaration, constant declaration, signal declaration, function definition and procedure definition. Okay, so here I am considering that particular function definitions. Okay, so but anyway, later I will explain how we are supposed to define that particular function, how to write a program for that. But at present what I am considering is, so here my intention is to convert whatever input I got. Input is N0, N1, N2, N3. In binary form we are applying inputs for that. So that I am going to converting into integer. To achieve that, we are supposed to consider the function. By means of function definition, so we can able to achieve that converting of signal type, one signal type to another signal type. Here my intention is converting from std underscore logic underscore vector. That is the type we assigned for this particular input here in the entity declaration part. So my intention is to converting that particular std underscore logic underscore vector, that binary form into the integer form. So that I am achieving by means of the using the function. So here I am directly mentioning that particular function. Anyway, later I will explain. So how to write that particular function declaration. Okay, but here directly I consider that. So this is the function. Actually, this is a function call. Okay, so convert underscore conv underscore integer. Okay, so within parentheses we are supposed to mention the input for that particular function. So here that particular function need to perform the operation of, it is going to take input as binary and it needs to convert it into integer and it needs to return that particular value to that particular variable. So that is what the functionality of that particular function we are supposed to perform. So because of that, here I am writing a function which is convert underscore integer. Within parentheses we are supposed to mention what is the input that we are applying for that. Okay, so because of here binary form of that particular prime number data input only we are going to apply, which is n itself. Because of that, within parentheses we mention that particular, anyway we can call it as a formal parameters. Okay, all this technology you can get while I am explaining the function declaration part. Anyway, after completion of this particular one, later classes I will define so how to declare that particular functions. Okay, and how to write program for that. Okay, later we will discuss, but at present, so think that, so here I call that particular function. So what it will do, it is going to convert the binary form into integer. So because of that, that binary input I applied, so based on that it is going to convert that particular integer and that particular function is going to return back to the variable. So here I am considering a temporary variable which is ni. Okay, so here what are the values it is going to get? So it is going to convert that particular binary into integer. Because of that name of the function also I mentioned converted into integer. So that integer value will be assigned to this particular temporary variable. So because of there is no physical significance of this particular variable, simply I am using to store that particular integer for operation purpose only that I am defining. but in circuit there is no physical significance. So because of that, this particular value, integer value, I am assigning to temporary variable. That too because of, so this ni is not yet defined in entity declaration part. Here only I am going to consider, that too within process that I am using. So within process you can't able to define signals, you can able to define only variables. So in that regard, whatever additional signals that we are going to consider within the process, all those must be considered them as variables only. Okay. So because of that, here ni becomes a variable. For that particular temporary variable, we are assigning the integer value, and while you are assigning, the assigning operator must be colon equals to, because here the value we are assigning for the variable. So in that regard, so the operator that we are supposed to use is colon equals to. For signal means less than equals to. Remember the difference between them. Okay. Then because of that, so here I am defining the variables. Anyway, within process only you can able to declare the variable declaration part. So here I used the one variable which is not yet defined previously. So because of that variable ni, where that I mentioned the type of that particular variable is integer, because after conversion of this particular binary value, this function is going to return the integer value within this particular ni. So because of that type must be integer. So in that regard, I declared this particular variable declaration before starting of the process body. Okay, same as previous one, what I said in architecture, once if you write this particular process body, it's better to declare the variables after declaring this particular process body. Okay, but anyway, first statement is this particular one. So by means of this, so what I got here, I convert by means of function, we converted binary value into integer, and that integer value will be assigned to ni. Next, coming to the functionality, here I am using the if statements. So first, that too nested if then else statement. So coming to that, first if ni equals to 1. So while coming for binary values means within single quotes and double quotes we are supposed to mention, but while coming for this directly you can able to describe the integer value. This is one more flexibility that we have. Okay. So coming to that, if ni is 1, so this whole thing is a Boolean expression. So Boolean expression nothing but it combines Boolean terms using VHDL predefined built-in operators such as and or not. So this is a Boolean term, this is a Boolean term, and these are all combining with respect to the so built-in operators such as and or not. In this particular case are, where Boolean terms are nothing but Boolean variables or results of the comparisons. Here I am comparing ni with 1. So by means of the relational operators equals to, in this particular case I consider. So now what happens? So whenever compiler comes to this particular statement, it verifies. So whether whatever value we applied, that particular integer value is equals to 1 or not. If it is 1, then obviously it's a prime number, because of that output f must be assigned a value of 1. So here this is not an integer, it's a binary, because f we mentioned it as std_logic. So in that regard, 0, 1 or other 7 values you can able to assign. That too here f is we mentioned in the entity declaration part, because of that is a signal. So because of that is a signal, the assigning operator must be less than equals to. Remember it. Okay. So if ni equals to 1, then obviously anyway our operation, any one of this one is true, then obviously these are all the statements it is going to execute based on the previous syntax. So what is the syntax? If Boolean expression. So this is the Boolean expression, then these are all the sequential statement. Here we use the single sequential statement. Okay. Suppose if ni is not equals to 1, then it comes to this particular one. If ni equals to 2, if this is true, then in that particular case also output f will be assigned a value of 1. Suppose if these two are false, if this particular Boolean expression value becomes false, then obviously control comes to the next statement. Then while coming for here, so else if ELSIF, not ELSEIF. So no E is going to present over here, remember it. So else if, and there is no space between S and I. Okay. So while coming for else if, so next I am going to verify other combinations, input combinations for the prime number. Anyway, we know the prime number 1, 2, 3, 5, 7, 11, 13. All these are all the prime numbers. Here I covered 1 and 2. So remaining all combinations I covered over here. If ni is 3 or ni is 5 or ni is 7, ni is 11, ni is 13. If any one of this particular input combination occurs, then obviously we are supposed to assign output f value will be 1. Okay. So because of f is a signal assigning operator only, we are supposed to use that to that signal type is std_logic. Because of that, in those 9 values, any value we can able to assign. Here I assign a value of 1. So that belongs to binary now. Because of that, only within single quotes we are supposed to mention over here. But all these are all integers. For integers, there is no need to mention single quotes and double quotes. Remember it. Okay. So because of that, f assigned a value of 1. Even so, I can also write all these over here itself. Okay, here itself. So ni equals to 1 or ni equals to 2 or ni equals to 3 or ni equals to 5. In a single statement also I can able to mention. But to consider else if and else statements, so here I divided that particular one. Okay, because whatever the sequence is same for both. So because of that, so all these I can also able to write over here. Continuation of this particular one. Okay, but explanation purpose only I divided it. Else if also I am supposed to use. In that regard I consider. For these two combinations I covered with if. In remaining prime numbers I covered within this particular else if statements. Then finally it comes to the else. Okay, if this particular in else if also, if all these Boolean terms so becomes Boolean expression, this whole Boolean expression become false, then obviously next control comes to this particular next statement. So in this particular case we mentioned else. Else sequential statements. So that is the sequential statements that we mentioned. F less than or equals to 0. So because of while you are assigning values to f, those are all binary values. In that regard, single quote. Single value means single quotes. Okay, multi bits means then double quotes we are supposed to mention. So in that regard, f less than or equals to 0 within single quote that we mentioned, then we are supposed to close it semicolon. Then finally we have to close this particular if statement. So in that regard we considered end if. Okay. So for if only we are supposed to end that particular one because of that end if only, not for else if. Okay. Else if it don't have any end if. Okay. But while coming for if, it consists of we are supposed to end that particular one with end if. And one more thing you are supposed to remember is there is a gap between end and if. Okay. So this is what, with this we close with this particular if statement. Then after that, so here I mentioned begin, we are supposed to close that particular process by means of considering the end process. Then after that one more begin over there for the architecture. That architecture also we are supposed to close by means of considering the end architecture name. Don't forget to end any particular. Okay, so whenever whenever we have the begin statements, obviously for that to terminate that particular begin, we must include the end statement. Okay, don't forget. So here for if, this is the first end if statement. And here we mention begin within process. For that we are supposed to close that particular process. That is what end process. And here also one more begin, that is for the architecture. We are supposed to close that particular architecture as well by means of end architecture name. And after writing this particular program, now you verify, so is there any signals or variables we are supposed to declare over there. Anyway, within process that we are using only variables. So because of that, if anything is there, then if any signals that we not yet used, not yet declared in the entity declaration part, those must be defined as variables. So if you look at this particular one, so other than ni, this f was already defined in the entity declaration part. This n also already defined. Only undefined part is ni itself. Okay, that is the only one newly we considered within this particular process body. So because of that, that must be defined as a variable because this ni we are using within the process. So within process you can't able to declare the signals. We can able to declare only variables in that regard. So here I considered So that variable declare, only that is the only one, so newly we considered over here. Because of that we assigned it as a variable. That too the type is, we are dumping integer values within that. Because of that type must be an integer. Okay. Then after that, so this is okay. So that's all regarding that particular program. And this is how to develop a program by means of using the if statement. So same program you can also write in any form of the if statement. Okay. So like a simple if or else if. Okay. If else or nested if then else statement.